A very important factor in the lifetime of a transformer is the condition of the insulating paper used in the windings. The solid insulation provides both mechanical strength and electrical insulation. Over time, the paper loses strength due to aging. If it becomes too brittle, it cannot resist the mechanical forces that can occur in the case of a fault. At worst, this could lead to collapse of the windings and catastrophic failure.
The end of life of paper could be determined by looking either at the tensile strength or the DP value. The DP, or degree of polymerization, represents the length of the fibres in the paper chains. The higher the number, the longer the fibres and the stronger the paper. New paper has a DP value of around 1000, and as it ages, its fibres are broken down. They become shorter and the paper loses its tensile strength. When the tensile strength has dropped below 50% of its original level and the DP level has dropped below 200, the paper can be said to have reached end of life.
Laboratory studies have shown that the type of insulating fluid used in the transformer has a big impact on the aging rate of the paper. The way the fluid interacts with moisture is particularly important, and this is where ester fluids, such as Midel, have a distinct advantage over mineral oil.
One accelerated aging study conducted by paper experts Weidmann Electrical Technology showed the benefits of using ester fluids. Cellulose pressboard samples immersed in mineral oils reached the end of their life after 2 months when aged at 150 degrees centigrade. In comparison, at the same temperature, similar pressboard samples immersed in natural and synthetic esters retained a DP value of over 200 after 4 months. Crucially, the results from the Weidmann study shows that both natural and synthetic esters confer the same benefits in terms of paper aging.
The IEC and IEEE have summarised the paper aging benefits of esters in their recently published standards regarding high temperature insulating materials. In these standards, the unit life paper aging curves based on kraft paper and thermally upgraded paper give an indication of the differences between esters and mineral oils. To take the kraft paper example, if ester fluids were used, the life of the cellulose would be approximately 5 times longer than if mineral oil had been used at an operating temperature of 95 degrees. Alternatively, the transformer can be run approximately 16 degrees hotter with ester for the same life. The key advantage to running the transformer hotter is that it can be made more compact using less raw materials in manufacture whilst maintaining the same power output. These benefits will be increased if thermally upgraded paper is used rather than standard kraft paper. The lifetime could be increased by as much as 7 times, or the temperature could be increased by up to 20 degrees C.
The paper aging benefits of esters can be very useful in managing assets on the network. This is of growing interest to the asset managers with the introduction of ISO 55000 and also the wide adoption of health index strategies. To find out more about how esters can help asset managers, view our video on ISO 55000.
Thank you very much for your interest in Midel. If you'd like to learn more about our product, then please do give us a call.